In this video, we're going to look at ranking task for change in velocity. In other words, acceleration. So we have 6 cases here, and we're asked to rank them by acceleration from least to greatest. We're told that the time interval is 1 second, although really it doesn't matter as long as the time interval is the same for all of them. We know that acceleration is equal to delta v over delta t. Velocity is a vector, acceleration is a vector. We look here, and for each one, I'll just write it out here to the side, the acceleration for case A is equal to the final velocity, which is 10 meters per second, minus the initial velocity, which is 5 meters per second, divide by 1 second, and you can see that we have an acceleration of positive 5 meters per second squared. And then I'm just going to go through this for each of the 6 cases. So for this one, we have 20 minus 15, and I'll just put my units outside the parentheses here, divided by 1 second. And this one is the same as A, 5 meters per second squared. In case C, we have 0 as the final velocity, minus 15. Okay, so it's a positive 15. I should say that we are using the positive direction as to the right. Okay, so we said this was positive, 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 positive. All of those values were to the right and positive. So here, this one was moving to the right but slowing down, and it has a negative acceleration. Now we get to case D, and we have these 2 velocities going to the left. So it doesn't say so, but we get to make them negative. What they are really showing here with these V's, they're showing the speeds. So they gave us all the speeds, and it's up to us to pick a coordinate system and then to fill in the appropriate plus and minus signs. So that's a tricky part right here, but that's important because we really want to focus on knowing which things are vectors and which things aren't, knowing when signs are important and when they're not. So here we're finding acceleration, which is delta v over delta t. So direction is important because velocity and acceleration are both vectors. So the acceleration for D is equal to the final, which notice here the final one is on the left, whereas before it was on the right for our other 3 cases so far. So it ends up here. So we say negative 10 meters per second minus negative 25 meters per second. And so the acceleration for case D is positive 15 meters per second squared. For E, it is 25 meters per second minus 25 meters per second over 1 second. Or if we just looked, we see the velocity is the same before and after, and so the acceleration is 0. And then last is the acceleration for F. So the final velocity here is, look at this one, it's to the left, which means it has what sign? That's right, negative 10 meters per second minus positive 25 divided by 1 second. And so the acceleration for F is negative 35 meters per second squared. Now we can rank them, and we look. Let's see, I didn't leave a lot of room on this one, so we'll just write our rankings up here. So F is the least. Okay, it says negative acceleration. Negative accelerations are lowest, so it's the largest negative value. And then we've got case C, and then we've got case E, which is 0. And then we get into the positive ones, which are A and B. That's a tie. And then the greatest one was D. Okay, so when we have a tie, remember we just show them together like that. Or we could have put an equal sign right between them. All right. And if we think about this one, we can also go into a little bit of detail about velocity, or just a review about velocity and acceleration. Here we have positive velocities and a positive acceleration. So velocity and acceleration in the same direction, speeding up. Same thing for B. For C, we have positive velocity. Okay, it is 0 at the end, but all during this in-between time, it's positive. But the acceleration is negative, slowing down. Here we have negative velocities, positive acceleration, opposite, those are opposite signs, and that object is slowing down. Here, of course, 0 acceleration, and then here, this one actually, it's changing from negative to positive, and so that one's a little bit harder to categorize. All right, that's all for this one.